My name is Guy Wagner, and I'm a director at Electronic Cooling Solutions in Santa Clara, California. One of the most interesting projects I've been working on is the cooling of a deep learning machine that uses neural networks. The neural networks are on 84 ICs on a board that is 20 centimeters on a side and dissipates 17,600 watts of power and requires liquid cooling since air cooling cannot handle this type of power level. The ICs are pressed against a cold plate that has microchannels on the back, and we used 30% ethylene glycol water coolant that flows through these microchannels at 20 gallons per minute. The coolant is pumped through the microchannels in parallel channels so that each IC gets the same amount of coolant flow at the same temperature. By using SimCenter Flotherm XT, we were able to model all the microchannels and all the passages within the module. And as a consequence, each IC runs at almost the same temperature, which was one of the requirements for this machine to work properly. We used the SimCenter Flotherm XT to optimize the spacing and dimensions of the channels within the unit to give us a fluid flow to each IC that was identical to all its neighboring ICs. This kept the temperature of all the ICs within a very narrow range, which was necessary for the proper operation of this learning machine. SimCenter Flotherm XT has given ECS the capability to model our clients' products in detail. We find that we are using it more and more for each job that we get because it does two things for us. It allows us to model the exact CAD as the customer would like to see it, and it has capabilities that exceed the previous generations of CFD software.